Hey everyone, and welcome. If you're looking to absolutely lock in some guaranteed marks for your CUET exam, you are in the right place. Today, we're diving into a topic that is a total goldmine: carboxylic acids. Seriously, this isn't just another chapter. This is your official score booster.
So, are you ready to master the concepts that examiners just love to put on the test? Stick with me because by the time we're done here, you're going to be able to look at any question on carboxylic acids and answer it with total confidence. Let's do this.
Okay, here's our game plan for today, our little mastery funnel. We'll kick things off by figuring out why this is such a score booster. Then we'll uncover the secret behind their super high boiling points, nail down the 5 reactions you just have to know, look at some real-world stuff, practice a few exam questions, and then we'll wrap it all up with a killer memory trick and a quick recap. Let's get into it.
So first things first, why is this topic such a big deal for CUET? Well, it's simple, really. The questions they ask from this chapter are super direct, they're logical, and they're just perfect for testing your fundamental concepts without any crazy complicated tricks.
The whole story, everything, revolves around this one guy, the carboxyl group, or minus C double bonded to an O. Its unique structure is what gives it all its special powers. You've got a carbonyl group, that's the C double bonded to an O, and a hydroxyl group, the OH, all on the same carbon. If you can understand this one little group, trust me, you've understood the entire chapter.
All right, let's get into the first big secret. I can almost guarantee you're going to see a question about why carboxylic acids have these ridiculously high boiling points. So let's break down the why right now so you never ever forget it. So the key phrase here is hydrogen bonding. But hold on, this isn't just your regular everyday hydrogen bond. Nope. We are talking about an exceptionally strong force between molecules that lets them do something really, really cool.
And this is exactly what happens. Picture this. 2 carboxylic acid molecules come together and they form 2 strong hydrogen bonds between them. This creates this super stable structure we call a cyclic dimer. It's kind of like 2 molecules holding hands really, really tight. This effectively doubles their size, which makes it way harder to pull them apart and boil them into a gas.
And this chart here just puts it all into perspective. If you take molecules with a similar mass, carboxylic acids are right at the very top of the list for boiling point. They're even higher than alcohols, which also do hydrogen bonding. That dimer formation we just talked about, that's the secret sauce, the big difference maker. So, here is your takeaway, the absolute key point. When CUET asks you this question, and believe me, they will, your answer has to include these 2 phrases: strong intermolecular hydrogen bonding and dimer formation. That's it. That's the full marks answer. So lock that one away. Okay, moving on to how these things react. Now, you don't need to know every single reaction out there. That would be crazy. For CUET, there are 5. Just 5 high-yield reactions that you absolutely must know inside and out. So let's nail these down one by one. First up, the reaction with an active metal, like sodium. It's pretty straightforward. The acidic hydrogen on the COOH group just pops off, and the sodium jumps into its place, making a salt. That hydrogen that left then finds another hydrogen, and poof, you get hydrogen gas bubbles. This is the classic textbook test that proves it's acidic. Now, this one is super important, so pay attention. The reaction with sodium bicarbonate. What's so special about it? Well, you get this fizzing, this brisk effervescence, because it releases carbon dioxide gas. So here's your exam clue. If you see something about brisk bubbles with sodium bicarbonate, your brain should immediately scream carboxylic acid. Reaction number 3 is Fischer esterification. It sounds fancy, but it's really just the name for making an ester. You take a carboxylic acid, you mix it with an alcohol, add a little acid catalyst, and you get an ester plus some water. Now, the huge glue for you in an exam question is that esters have these nice, pleasant, fruity smells. You see fruity smell, you think esterification. Simple as that.
Next on our list is making acid chlorides, usually with the reagent like thionyl chloride, that SOCl2. Now, this might just look like a simple conversion, but trust me, it's a critical first step in a lot of those multi-step synthesis problems you'll see. Knowing this reaction is going to be key to solving those trickier MCQs.
And finally, our 5th must-know reaction, decarboxylation. When you take the sodium salt of a carboxylic acid and heat it with something called soda lime, it basically forces that carboxyl group to just leave as carbon dioxide. And here's the crucial part.
The carbon chain gets shorter by exactly 1 carbon. So always be careful with your carbon counting in these questions.
Okay, so we've got the theory down. Now let's see how this stuff actually applies in the real world. And, more importantly, let's look at a critical distinction that CUET absolutely loves to test you on.
Remember that sodium bicarbonate test we talked about? Well, here's why it's a total superstar. See, both carboxylic acids and phenols are acidic. But, and this is a big but, as you can see in the table, only carboxylic acids are acidic enough to react with a weak base like sodium bicarbonate and produce that CO2 gas. Phenols just aren't strong enough. This is the single best test to tell them apart.
And hey, don't forget about their real-world uses. These are easy marks. Acetic acid, that's just vinegar. Benzoic acid, it's a food preservative. Formic acid, used in the leather industry. These can definitely pop up as direct one-mark questions, so it's good to have them in your back pocket.
All right, theory time is over. Let's put your knowledge to the test and make sure you don't fall for any of the common traps that catch other students. It is time for some practice.
Okay, here are 2 questions, straight out of the CUET playbook. Question 1. Which reagent can distinguish a carboxylic acid from a phenol? Is it A, sodium, B, water, or C, sodium bicarbonate? And question 2. The reaction of a sodium salt of a carboxylic acid with soda lime is called what? A, esterification, B, decarboxylation, or C, saponification? Okay, I want you to actually pause right now and write down what you think the answers are. Go on, hit pause.
Okay, did you do it? Let's check your answers. For question 1, the correct answer is C, sodium bicarbonate. Remember, it's a weak base, so only the stronger carboxylic acid is going to react to make that CO2 gas, not the phenol. And for question 2, the answer is B, decarboxylation. Remember, decarbo literally means you're removing that carboxyl group as CO2, which shortens the chain. So how'd you do?
Now listen up, because this is important. These are the top 3 mistakes I see students make all the time. First, they get the NaHCO3 test mixed up with other reagents. Second, they mess up the carbon counting in decarboxylation. Always remember the chain gets shorter by 1. And third, they forget the boiling point order, that acids are higher than alcohols. Do not let these simple slip-ups cost you precious marks.
We are almost there. We're in the home stretch. Now it's time to lock all of his knowledge into your brain so it's fresh and ready to go on exam day. Let's get to our memory tricks and a final recap.
Here's a super simple way to remember all the key features. Just remember the word acid. A is for the acidity shown by that all-important NaHCO3 test. C is for the chain shortening that happens in decarboxylation. I is for the intermolecular hydrogen bonds that form those dimers. And D is for the delicious, fruity smells that you get from esters. Simple, right? Write it down, ACID. And now for your final rapid-fire revision. Ready? High boiling point. It's because of H bonding and dimers. The key distinguishing test. It gives off CO2 with sodium bicarbonate. React it with an alcohol, you get fruity-smelling esters. Heat it with soda lime. You lose 1 carbon and the chain gets shorter. That is the core of this entire topic, right there. So how did you do on that little 2-question quiz? Be honest. Let me know your score down in the comments below. If you got a 2 out of 2, awesome. If not, no worries. Just go back and review that specific section. Every single student who wants to ace their CUET is going to master these concepts, and now you can too. If this breakdown helped you out, make sure you subscribe for more score-boosting guides just like this one. Keep up the amazing work, and I'll see you in the next one.